There we go. So yeah, you can watch this afterward and see your voice, and yeah, it's not funny. It's funny, but it's not like goofy wacky. It's just scrambled. Yeah. So it's not like you sound like a loser. It's like we literally can't understand you. So that's it. Luckily, it's pretty easy stuff today. So I guess the only real question is, did anyone have any trouble?
I don't. I think I understood everything.
Yeah, I really think we'll be able to finish this real quick. So, like I said, I didn't do the quiz. I looked at the quiz, and there's no calculation. Well, there's some calculations, but it's like more like basic math than statistics right now. Maybe next week will be harder. But if you got the questions 5 and 6 right, you'll be able to get the rest of them. I think.
Okay.
I kind of skimmed through it. So
Yeah.
if no one had any trouble, okay. Well, I guess we really should do part 2 together because that's what we're supposed to do, even though it's pretty simple. All right.
Yeah.
So unless anyone has any questions or things they want to bring up, I'll just start reading number 5. All right. An 8-sided die has 8 possible outcomes for each roll: 1, 2, 3, 4, 5, 6, 7, or 8. Calculate the probability of rolling a number greater than 5. So there are 3 numbers greater than 5.
Yeah. So
It's 3 8s.
possibility.
Yeah. So
Each one is a possibility, right?
Mm-hmm.
Each number is a possibility.
Each number is one possibility. And it was extremely simple for a practice problem. It's really throwing me off because I feel like we had more trouble than the other ones. Whatever.
Yeah.
All right. And since this next one's short, I'll just go right to the next one. Calculate the probability of not getting a number greater than 5. Which... which we can... You can do what they said and do like 1 minus the probability, but you have to convert that into a decimal. So if you do 8 minus the 3 you have up there, that's the possibility that it won't happen versus the possibility that it will. So that is 5, so 5/8. I'm just trying to extend this because really, I mean, you can kind of tell just by looking at it.
Yeah.
So I'm trying to make it seem like it's more complicated. But yeah. Well, any questions? And are we ready for the quiz?
I think we're ready.
All right.
I'll just let me find it really quick.
Okay. Hold up. Okay. Right.
Okay, I'm ready.
All right. So let's go ahead and open the quiz and answer the first 2 questions on your own. It's
Yeah. Got it.
But it's both going to be true. All right. All right. Then I'll read the graph, and then you and I, well, those of us who can talk, will switch back and forth between the questions. Like just reading the questions, and we'll just talk about. Okay. Whenever everyone's ready, I'll start. All right.
Yeah, I'm ready. You can start whenever you want.
All right. So So the first question is a graph. Okay. Human blood can be classified into one of our basic types: O, A, B, and AB. The proportion of the people of the population in the United States with these blood types is summarized in the following table. So O is 0.45, A is 0.4, B is 0.11, and AB is 0.04.
So all those numbers added give you 1, right?
Yes.
Okay.
Which gives away our question. Well, which gives away our question 3. Blood types and proportions given in the table defined as a probability distribution, which it is. I mean, you can kind of look at them as just numbers, but all those numbers do add up to 1. In the first, or was it the second rule? Was all the probabilities add up to 1? So yeah, right.
So question 4, what is the probability that a randomly selected person in the United States has type O blood?
This one is too easy.
Rounded to the decimal place.
So yeah, it's
0.45.
Yeah, 0.45, because, well, it's right up there. So, all right, and I like question 5. Okay, the probability that a randomly selected person will not have type O blood. So we can either do this by adding, a number to make the 45 100, which is 0.55. Oh, well, 1, which is 0.55. Or we can do what they say to get the opposite, and 1 minus 0.45, which is 55. But this is simple enough. You can just eyeball it.
Yeah.
Yep. And next one. Can you read this one?
Yep. Caroline Williams and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Question 6. If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
Okay. So this is kind of like, if it is random, it's like rolling a dice, but it'll be 7 outcomes. So you could say it's a 1 in 7 chance, but they want a decimal number. So you can either do some fancy converting to convert 1 7, or you can just do what I did. 1
over 7. 1 over 7.
Yeah, 1 over 7, or 1 divided by 7, and round that adds to 0.143, which probability. Yeah, and then my regular calculator says that's 1/7. Nice.
It is, how much is, what's the number?
Oh, it's 0.1428 blah blah blah, but it's actually, but round up, it's 0.143.
Got it.
Okay. Oops. Okay. I'll read the next question. In the combined totals 54 trials, the dogs correctly identified the specimen from cancer patients 22 times. It is very unlikely the dog would do this well by random chance alone. Which of the following statements is most appropriate? All right. Statement 1 is this provides a strong evidence that dog can detect bladder cancer. The other is there's little evidence that dogs can detect bladder cancer. Okay. What does our squeaky muted friend say? No. Yeah, it kind of gives it away in the what do you call it? In the question, it just says it's kind of like pointing it out obviously like. But I guess if you wanted to be fancy, you could, 22 divided by 54 for the amount times it was corrected versus the how many trials, which you get about 0.4 or 0.41, which is more than the random 0.143. So that's a more mathematical, scientific way to prove it right, but yeah. Anyway, M&Ms.
Okay, so in other words, it's the first statement.
Oh yeah, the first statement.
Yeah.
Because the trial proves the probability is greater than random.
Okay.
So, all right, then.
Okay, I'll read it. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. Okay. Okay. Question 8. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
Well,
it's right there, right?
It is right there.
0.13.
Right. We'll move. That's 0.13. We will move to the next one. Question 9. What is the probability that a randomly selected candy is green? Around the 2 decimal places. And green is hidden.
Yeah.
But this is a very, I don't want to say easy puzzle, but we've learned that second law, I think it was the second law, that these add up to 1. So if you add up all the numbers, 14, 13, plus 24, blah. I messed up. Okay, adding all those up, that adds up to 84. So I'm just going to subtract, 0.84, subtract it. So that means what's left over is 0.16. So I believe it's 0.16 to get a green candy. All right.
Okay, question number 10. What's the probability that a randomly selected candy is not green? So
yeah,
it's 1 minus 0.16, right?
Yeah, 1 minus 0.16. It's 0.84. So you can also just add up all the other probabilities, but that will take longer because 0.84 was everything but green added up together. That's fun. Fun stuff. Doesn't math make so much sense? It does. Okay. So next. All right. The next question. The ATC scores of students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Okay, so I'm not going to read all the numbers,
Yeah.
We're
That's
gonna
fine.
I'm just gonna skip to question 11. Half of the observations are less than or equal to what number? Oh, these are review questions. All right. So half less than or equal to what number? So that would be like the second, well, the 50%. So that would be the median. And the median is 24. So so the answer I think is 24, because if that's the median, then that's the second quartile, which is, we learned quartile is like whatever it
Yeah.
is, it's more equal to or more than everything below. Well, yeah. Quartiles.
It's 24 then, right?
I think so.
Question number 12. Based on information on the table above, the top 25% of the students score about what number?
Oh.
25, that's the first.
25. The top 25 would be, that would be, oh, so that would be 75% and more.
So
That would be top 25. So it would be the third quartile.
third quartile, yeah.
So then I guess it's
27.
right. The answer's right there, 27. All right. All right. Let's wrap this up. Which of the following is not one of the three rules of probability? Is not one of the three rules of probability. Okay. I don't know what order you read them in, so I'm going to read them in my order. Okay. The
Okay.
probability that an outcome will not occur is 1 minus the probability that it will occur. That's the third rule. Okay. A probability is a number between 0 and 1. That's the
True.
second rule. No, the first rule. All right, whatever. Doesn't matter. If the probability is high, then the probability is positive. If the probability is low, then it's negative, which is not,
That's the answer.
because it can't be negative.
Yeah.
All right.
Okay.
Wow. I think that was kind of easy. So
Any are you do you agree, Trent?
yeah. I think got everything. Carter, did you miss anything? Like, well, not hear any one of the things we went over? Okay. So yeah. Well,
So we should go ahead and submit it.
yeah. I guess if you want to check your questions, go for it. But I'm pretty sure we've got it all right. I mean, so I'm going to submit mine. Okay. All right. And I got 100. So if either of you didn't get 100, it just means we just miscommunicated a number.
I got 100 too.
All right.
Okay.
Okay. So awesome.
Okay. So question is, when do we want to meet?
I think we've decided we're going to regularly
Monday.
meet Mondays and Wednesdays at, what was it, 3?
Yeah, 2.
Or is it 2?
Yeah.
Or is it 1? I don't remember. I'm like exactly 2-hour time difference, so it's like If it's 1, it'll be 3. If it's 3, it's 2. And I'm kind of messed up. I don't remember when I was supposed to be here.
So
like next meeting. It was at 3, right? Mountain time.
yeah.
So I just have this horrible feeling, which I haven't looked at yet, that tomorrow is going to be very hard because this one was so easy.
Yeah.
We'll see. And if nothing else, we'll just push it back to Thursday if we're not ready. But yeah, we'll just keep in contact with each other.
So do you think, Trent, will you be ready for tomorrow, to meet tomorrow?
Definitely not, but I think we should be. Well, actually, no. Where is? Oh, how do I do this?
Okay, I can do tomorrow, and Trent said he can do tomorrow at 3.
Yeah.
So
it's 3. I'm trying to schedule. Oh, here we go. So tomorrow would be lesson
4.
4, yeah. And okay, I don't know how hard it will be, but it'll be about the same length as today. Well, wait, is it? No, that's what we read today. So it'll be lesson 5, right? Yeah. Okay. We got bell curves. Is this the right one? Whatever. All right, we'll just get to it if we get to it. But I think is it bell curves? Lesson 3, lesson 4, 2. Oh,
lesson 5.
That's weird. Okay, so maybe it is lesson 5. Okay.
Yeah, it is lesson 5.
And lesson 5 is curves, averages, probability. So I think we should be okay. It doesn't seem like a ton of stuff. So, and if it doesn't look too hard. So I think we should be okay by tomorrow. But if we're falling behind, just let everyone know we might postpone it. All right. Other than that, I think we are good to go.
Yeah. Okay. So tomorrow at 3 then.
Tomorrow at 3. And all right. And when we do this, what's her Laura? Let's give Laura participation. But what about Avery? Oh, we'll just text him. But like, Allison, is it? She didn't come to the meeting, she didn't reply that she was going to miss our meeting or anything. So I guess one of us should email her and see if.
I texted her, letting her know that we were meeting today, but didn't hear anything back.
So I don't know what's going on with her, but yeah, just whenever we post this, keep him. We can do kindness to be hard for Allison, but Laura, I'd like to give her as much credit as possible because I didn't look at it, but she said she emailed her homework over and she did her best to communicate. Other than that, I think we're good to go.
Okay. So I'm gonna text Laura and Allison to let them know that we're meeting tomorrow.
Yeah, tomorrow at 3. All right. Okay.
Trent is posting this video, right?
Mm-hmm. Oh, this is Trent's video, right?
Yeah.
Okay. All right. Thank you very much. I'm going to go and I guess finish my dinner.
Sounds good.
I'm glad this was quick. All right.
Bye.
All right. Bye.